All right, here we go. So let me clear this page. Before I get started, I want you to answer this question. I want you to answer me this question. Okay? It's not a difficult question. I think that you can reason through that, right? What should x be?
3.
It should be 3, right? But when we're doing math, that's not really the way we ask this question. That's not really the way we ask this question. We really ask the question like this. That would be the proper way to ask the question. Okay? Because all we're asking for when we do logarithms, we're asking for an exponent. What is the exponent that makes this true? So one thing that you need to remember, or to know, I'm going to go ahead and write this as a power. Base exponent is equal to some answer, right? If you want to convert that to a log, because you can, and it's bidirectional, this would become log of the base answer is equal to the exponent. And the log is simply asking for an exponent. That's all it is. Just like when we see a plus symbol, we're looking for a sum. When we see the x for multiplying, we're looking for a product. Whenever we see log, we should know that we're looking for an exponent. Okay? That's all it really is. A lot of people get, I even get messed up with this because we're not used to thinking about it that way. It's so late in our math when this is introduced that it's kind of hard to throw in new stuff. But I think we should be fine if we understand that the idea that this is simply asking for exponents. Okay?
Yep.
So, can I change the slide?
No.
No, let's not. What happened to the rest?
She's down there.
Oh, here you are. Oh, yeah. Yeah? Okay. No?
No.
Oh, thank you. One of the advantages is that here I can actually just ask the question without making an equation out of it. See that?
Yeah.
So I can simply ask you, hey, what is this number? And you can bet that's the number that you're looking for without having to bring variables or into this problem. We're good? All right, let's see here. Next slide. Definitions for logarithmic functions. If you're going to work with a logarithmic function, x has to be greater than 0. B has to be greater than 0. B cannot equal 1. And of course, I think I already talked about this equivalent a minute ago. Of course not. Oh, queda tostada. So, here's what I want to point out. This is a function log base b of x. And that's actually the way you write it, or you word it out. It's a logarithm function whose base is b. Okay?
You look so sad and it didn't work the first time.
I forgot it was the magic ink. Yeah. There was a teacher that used to write the notes with the magic ink. So you only had enough time to write it was up there because as I kept going, these are the notes. Make sure you get them because they will go away.
Cry.
I would cry. Oh my God.
It bothers me how the words disappear at once instead of like fading out from the left to right. The same.
I think it has to do with the speed at which I write it, so it's about the same. All right, so we're good with this slide? All right, let's mess around. Let's play. They want us to rewrite these expressions in their equivalent exponential form. In their equivalent exponential form. I'll give you guys a few seconds. You guys try that first. Salud. be on the lookout for my orange calculator.
It's yours?
No, it has the orange faceplate, my dear. That's yellow.
Yeah, you got wrong, cause I don't,
This is orange.
that is yellow.
It's orange.
That is green.
It's orange.
That's called school bus yellow.
It's
Yeah, you ride school buses, you should.
That
know
is-
yellow.
She's colorblind.
Okay.
You're an orange.
Narf.
Are you always?
So, you should have this here for the first one. Four to the y equals 26.
Don't know. It's like 2 point something.
I'm gonna say 2.1.
What'd you say it was? 2 point what?
2.1, that's my guess.
Not too bad though.
Wait, how did you?
Oh, it's gonna find.
I'll school you later. You saw me typing away, huh? I want to know. All right, can I move on? This was optional. I just did it because it was there. All right, let's go the other way. Let's go the other way.
Uh-oh. Yeah.
Yeah, yeah. All by myself.
No worries.
Obama's out. I wanna be. Lily, what'd you get for the first one?
I got log base 2 of x is equal to 5.
Log base 2
And there's an x right there.
x.
Is equal to 5.
Log base 2 of x is 5. Okay. How about the next one? Go ahead, Gunnar.
Log base B, 27 equals 3.
Beautiful. Finally. Hen. No beba.
Log base e is 3 equals 4.
Cool. All right. Let's move on. So now that you know that this is simply asking for an exponent, what is this question asking us? Let's. Do I have a dojo?
What's the x
Yeah, the question is, what exponent on 10 will give me 100? It's
2.
going to be 2. Good. 2. Because 10 to the second will give me my 100. So the exponent on 10 has to be 2. Questions there? Not too bad? Let's do a little tougher one here. What exponent on 5 is going to give me a fraction of 1 125th? Someone said something? It's going to have to be some negative, isn't it? Why negative? You want it to flip. So negative what? 3. So the exponent on 5 is going to be a negative 3 here. Good? Good. Any questions? Thanks, Kat. All right. What exponent on 36 gives me 6?
Wait, no. It's yes. 1 over 6.
Oh,
No.
no, gosh.
It's 1 half.
No, 1/2.
What is it?
1 half.
It's 1/2.
Because it's a square.
Yeah, so you got to think about this. So, and you can write it out if you want. What exponent on 36 has to give me 6? Well, the only way I could do that would be if I square rooted the 36, right? And if I did the square root of 36 and wrote it as a power, that is 36 to the power over index, which is 1/2. Okay? Okay, I thought I wrote 6. Questions on this one?
Wait.
Hold up. Wait. Are we good with this slide? Guys ready for a challenging one?
Wait.
What exponent on 3 gives me the 7th root of 3?
It's 1/7.
Oh, wow. You guys are good. Let me show you why.
Because it's 71.
It's pretty much the same thing. So for those that can't see it, I want an exponent on 3 that's going to give me the 7th root. That's not what I wanted. That's going to give me the 7th root of 3, right? So here's what I'm going to do. I'm actually going to use one of the first rules for powers or logarithms or exponents. Check this out. If I rewrite this, this is 3 to the 1/7, right?
Yeah.
And if the bases are the same, then the exponents are the same. So x has to be 1/7. Nice. Yay, another worker. Not okay? Okay.
What do you mean no?
No, I'm answering questions. Make sure we're good. We're good? Mika? You look like you're not trying to make eye contact. She's like, we're good? Alright, make sure you ask questions if there are any, okay? And we will want to make them the same base. We will force it to be the same base so that we can make sure that we can create equations there. But then then that would be just false. That would be straight up false. But they won't do that. Well, let me take that back. They might, and you'll have to say, this is not doable. But usually they will be. Because sometimes what they'll do is they might give you something like, where this ends up being like maybe a 9, not a 5. Cannot be a 5. Cannot be a 5. There's no way. But maybe this is kind of true. What would x have to be in this case?
Oh, wait, can you write it back in the page? Because isn't it the power? So it could be 3 to the power of 2, so would it be 2/7?
Mm-hmm. Okay, so if this is the question, we're going to do this real quick. this would be 9 to the 1/7, right?
Yeah.
But I want this to have a base of 3. So I can rewrite that
That's 2 sevens.
where 3 is simply, where 9 is 3 squared, correct? But that 9 is to the 1/7. And then I just use my rules again. 3x, this is equal to 2 sevenths. So x is, right? Look at all this math coming together again.
Wow.
Algebra 1.
Never understood logarithms.
Neither did I.
Is it making sense?
Last year. Yeah,
Good.
last year I hated them.
Yeah, once you understand what they're looking for, it's just an exponent. You should be fine. You should be able to take everything you've learned and apply it. Watch me say that and be like, I got lost now. All right. Here's some really cool properties you need to know that involve 1. If you have log b of b, guess what that's going to equal? It just equals 1. Because think about this. If they're saying, hey, you know what? Let's put some numbers in there. Let's go log 5 of 5. They're asking for an exponent on 5 that will give you 5.
1.
Well, that's just a 1, right? So whenever you see that, understand that you're just looking at 1.
That makes so much sense.
Now the other one is saying, the other rule is saying, log b 1.
Okay, because every time last year, well not last year, but when I was taking algebra 2, I would always use the logarithm and then the base, and I didn't know, and I didn't multiply it by anything, so it would always be 0, and I didn't understand why, and I was like,
Well, let's take a look at this one. This one is telling me that I've got some number to some power, and I get 1. So, I always get 1? That means that this number had to be to what power? 0. Because anything to the 0 power is 1, except for 0 to the 0 power. This is broken. So many answers on that one. We can't do that one at all. Zero to 0 power is undefined. Yeah, 0 to 0 power, guys, is undefined. There's just so many options, we don't know which one to pick. Someone was going to ask. Why did I even say anything? Okay, so just a quick, simple answer. Math needs to work consistently, 100% of the time. 0 to 0 power might work in the real number system, but once we include the other axes, which is the imaginary, then solutions can come in from any direction and head towards a different value. Therefore, there are infinite number of ways you can come at that, which means it doesn't work. Kind of like that whole limit does not exist type thing. So if there's multiple answers, then which one do you pick? You don't. They all have to approach the same thing. Therefore, it's undefined. That means we just have not defined what it's going to be yet. Go math. All right, here we go. Check this out. What is this log 9, 9? What's log 9 of 9?
1.
What's log base 8 of 1?
0.
Boom chakalaka. Moving on. Okay. Properties, inverse properties of logarithms. Can you guys see this okay? This says log base b, b to the x. Okay? Well, what's log b of b? No, just that. It's just 1, right?
1.
So what ends up happening is, it's like that 1 times x, it just ends up being x by itself. So if you see this business going on, it's like you can just drop that exponent down and it becomes a solution.
Okay.
Here, let me give you a visual.
Yeah, give us a concept.
I don't know what I wanted to do. Log base b. Here's the actual formula, right? Let's get rid of that. This is saying that some exponent on, let me call this question mark. Some exponent on b was going to give me b to the x, right? That's what I said a minute ago, didn't I? If the bases are the same, then the exponents are the same.
Yeah.
Therefore, if that has an exponent of x, then this should also have an exponent of x.
Yeah.
But visually, I can see it here, can't I? Oh, this is like just a 1, and then I'll just get that exponent as my
So
solution.
it'd just be 1.
okay, so it's like the same.
Yeah, but it's a visual thing. Kind of like this one here. let me show you the other one. I'll write a little bit bigger. This one says b to the log of bx
Isn't it just
is also equal to x.
Are we gonna get all this like
Oh,
Oh, yeah.
oh yeah.
Phone call.
Salud. But it's the same idea, isn't it? In
Yeah.
reverse.
Wait.
See how this is log base b to the b?
It's just they're switched.
Yeah. Now, if you want to see it visually, go for it. Okay? Base
5.
log of b, what would it be here? X?
Yeah.
Oh, obviously it's the same. Never mind. But here's what you can do. You can think about it the same way as this, where this would just become kind of like a 1, and then you just get that X. Right, because it's the same idea. Same idea there, okay? All right, here. What's this? Oh, wow, you're quick. Look at all that fancy. Look at that fancy 8 right here. That's a fancy 8. Questions on why that's 8? Anybody in the back? Moving on.
Look at my mom's.
How much is this?
17.
That's a fancy 17, isn't it?
Oh, yeah.
All right.
Oh, shit. What's the difference?
Graphing these. Oh, there's a difference.
Yeah.
With graphing, guys, if you want to graph them by hand, you're going to have to go primitive. Pick an X, spits out a Y, pick an X, spits out a Y. I think we're beyond that. You need to use this. Okay? Now, does anybody need help? Yes, you do. Let me show you how to graph these on an 84. So let me mesmerize this real quick. I want to minimize. All right, so first we're going to do 3 to the x. Oh, did I do them already?
This time you did it. Nope.
Oh, no.
Those are from yesterday.
All right, so top one, 3
The X.
caret. My caret is right here. It's right above the division.
Like carrots.
And then I'm going to hit x. So there's 3 to the x. The other one said,
Log 3 of
where's
X.
it at? Log base 3 of x.
You should just do that.
Okay? This one, there's a log button right here. But we'll talk about that one in a little bit. I want you to go to math. I want you to go to math, and I believe it's in here. If I push up, log base. Do you see it?
Yeah.
So I'm going to go log base. That'll give me a little box in here. See it? And then I can put my 3 in there,
Yeah.
and then I can put my x up front. Okay?
That. And then you would grab
Now, what should they look like? How different should they be? They should look alike they're by hand. So here's 3 to the x, which is exponential. And then the other one
It's like a log, so it's gonna
looks like this.
wait.
Now, there's a big piece missing.
Why?
It's this red one. It's really supposed to be coming down like, kind of like that. It's the reciprocal function of this guy.
Yeah.
Okay? Our 84s are stupid. They really are. So it knows that here, it's like the 0 value, so it's calculating all of that as undefined, so it doesn't even put it in for you.
But it's just the same.
But you should know that it's just like this one. It's asymptotic.
So it's just going
So
down
you just
to
do that.
0.
Okay?
Okay.
So you need to know that. Your calculator is flawed. There's only so much you can do. But please know that. Otherwise, if you don't, you fool. You're wrong. You guys can read that at your own pace. It's just talking about the domains and ranges of these. If we look at the blue one, what's the domain?
Negative infinity to
Negative to positive infinity, right?
Yeah.
Range,
0.
0 to positive infinity. Here, what's my domain? Well, remember, they just split, don't they?
Yeah.
Here, let's write that real quick. On the blue one, domain is negative infinity to positive infinity, and then the range is from 0 to positive infinity. And because this is the reciprocal function, then these two would simply swap their positions. Okay? Hiya. I can wait. Ah. Oh, you know what I could do? I could say range for the red one, domain for the red one. Yeah. Well, what? Is tornadoes Latin for something?
Yeah, those are good.
Okay. Same idea. Okay, take a look at this one. It wants to find the domain of that function up top. The domain of this function right here. Easiest way to see it? Graph it. It's going to be like one of those, like these guys, except it's shifted, isn't it?
Yeah.
Which way, left or right?
Right.
To the right. So that means that the domain here is going to go from, oh, there it is, from 5 to,
Right. That's what I thought. Yeah,
positive
'cause
infinity.
It's gonna be the. It
Okay.
would be the
so it'll look just
there.
like this red one.
Oh, well.
Maybe, well, not exactly, because this is a base 3, right? It'd probably be a little bit more square-like, but it's going to shift 1, 2, 3, 4, 5. So it'll do something like this, and it might be more square. Okay? Not a big deal?
No.
Thanks for putting your phone away. Let's move on.
Professional cursing.
We did that already.
20%.
Why do I have it twice?
I don't know.
Ah, here's what I want to talk about. Log base 10.
This one was weird.
It shouldn't be weird.
Log base 10. Well, don't
Here
cancel each
is
other out.
log base 2, we'll say 8. Okay? What is the base of this guy? Base 2.
Or, yeah, base
Okay? That means if we're changing the base of the math system that we're working with, it would be a 2. What base is our math system in?
2.
10.
It's in base 10. So whenever we're looking for a function, and it looks like this, we should understand. Remember how we don't put a 2 here? Because it's understood.
Yeah.
And if we have this, like an x, we don't say, oh, that's 1x,
Yeah.
because that's understood. If we have just log 8, it's understood that we're working in our natural base 10, okay? Which corresponds to this button right here that just says log. That is a base 10 button, okay? And that's the one you should be using the most. Now, if you need a different base, math, log base, okay?
I'm confused.
What?
What are you confused about?
Go ahead. What's your confusion?
How is it?
How's it what 8?
No, he was just making up a number. He's making up a number.
Oh, no, it's not.
Could be anything.
It was just an example. That doesn't work. Remember it was a 2? That's not real. That's not real.
Okay.
It's not real.
Okay.
I just was expressing the point that I don't have to write this. I would just write this as
Log X.
log x. This should have just been written as log x. You don't need to put the 10 there. And if you don't see it, then it's okay. All right. How are we on time?
2 minutes.
Write these down or take a picture. Or you guys can go on to the slides that are on MathLab and grab these. But I need you to grab these properties. There's some of the properties we went through right now. And they go both directions, right? You okay there?
Yeah.
I'll wait another second. Seconds. And then take these down also. Are they the same?
Yeah.
Yeah.
Log.
Oh, there's E. There's E.
Oh yeah, because you want E.
Okay.
Those are for your natural logarithms. You guys have this one?